In this video, we want to show how to use this table, the cumulative distribution function of the standard normal distribution table. The table shows the area under the graph on the left-hand side of a certain z value. For example, the value 0.00 has 50% on the left-hand side. So on the left-hand side of this mean, 0, we have 50%. Now, let's see how to use this table to calculate probabilities. We can take an example. Let's say we have a variable x that follows a normal distribution with a mean of 150 and a standard deviation of 25. If we want to find the probability that x is greater than 175, that is the blue area in the graph, then we take 1, which is the whole area under the graph, minus the probability that x is less than or equal to 175, which is the area on the left-hand side of 175. So 1 minus the cumulative probability function of x for 175, the area under the graph. But in order to use the table, we have to first convert our x into a z, because z has a mean of 0 and a standard deviation of 1. But we had a mean of 150 and a standard deviation of 25. So we standardize our value 175 by subtracting 150 and dividing by 25. So the value minus the mean divided by the standard deviation. So we get 25 divided by 25, and that is, we get a z-score of 1.00. So now we have converted our x into a z, so we can use our table. So what value do we want to find in the table? Well, we're still interested in the blue area, but the table shows the area on the left-hand side of a certain value. So we want to find this value, the cumulative distribution function of z for 1.00. So let's find that in the table. We wanted 1.00 as our z, so we look here, 1, where is 1? 1.0, and the second decimal is also 0. So these columns here, they show the second decimal of our z value. This is the first decimal. So we take 1.00, so that should be this value here. So the cumulative distribution function for 1.00 is 0.8413. So the area under the graph on the left-hand side of 1.00 is 0.8413. Let's remember that number. So we had this area 0.8413, and we want this area. So we take 1 minus 0.8413, and we get an answer to the original question. So the probability of x being greater than 175, the blue area, is 0.1587. That is 1 minus 0.8413. Now let's look at another example. We have the same variable, mean of 150 and a standard deviation of 25. But now we want to find the probability that x is less than or equal to 125. That is the blue area here. So we go 25 steps down from 150, and 25 steps is one standard deviation, right? So one standard deviation down from 150. And what do we remember from the last exercise? Well, if we look back, we have one standard deviation up from 150, this area. And because the distribution is symmetric, we know that this area should be the same as this area. So we get the same answer as in the last question. The probability that x is less than or equal to 125 is also 0.1587 because the distribution is symmetric, so it is the same size on both sides of the mean. Now let's look at the third example. What is the probability that x is between 125 and 175? Well, we had the areas, both this area and this area, in the previous two examples. So this area was 0.1587, and this area also 0.1587. So we could just take 100% minus this area minus this area. But another way of doing it is also to take the area under the graph on the left-hand side of 175. This, the distribution function for 175. That is all the area on the left-hand side of 175. And then we take minus the area under the graph on the left-hand side of 125. So all this area. So all the area up until here minus all the area up until here. And if we write that with our z variable, well, we would get a z-score of 1 here for 175 and a z-score of minus 1 for 125. So we remember from the last two examples that the area under the graph until here is 0.8413, which can be found in the table. And the area under the graph up here is just 1 minus 8413, which is 0.1587. So the area up here, up until here, minus the area until here is 0.8413 minus 0.1587, and we get an answer to the original question. And maybe you remember from the empirical rule that about 68% of the data lies within one standard deviation of the mean. Now let's look at a final example. We still have the same x variable with a mean of 150. But now we want to find the probability that x is below, less than or equal to a certain value. Let's call that value a. Another way of writing this is the distribution function for x for the value a. So the area under the graph until a. And we want that area or that probability to be 67%. So let's say we want 67% area under the graph on the left-hand side of A. So we can understand that A must be a bigger value than 150. Why? Because we have 50% on each side of 150. So 50% on this side, and we have 50% on this side. So if we want the area under the graph to be 67%, well then A must be a larger value than 150. Now how do we find this A value? Well, first let's convert our X into a Z score. So we take A minus the mean divided by the standard deviation. And we still want that area to be 67%. So the distribution function for Z until the value A minus 150 divided by 25 should be 67%. And that is shown in the graph here. Now what value do we find in the table? We want 67% of the area under the graph. So let's look in the table. Now we want the area under the graph to be 67%. Okay, and the area under the graph are these values here in the table. So let's find 67%. We have a value here, 67%. So what value do we have for Z? Well, for 67% here we have 0.4 and we have 0.04. So if we add these two values up, we get 0.44. Okay, so what did the table tell us? Let's go back to the example. The table said that the area under the graph on the left-hand side of 0.44 is 0.67. Well, that would mean that our value here, this value should be 0.44. This value should be 0.44. So we take 0.44 and we take this value that we're interested in. We set them equal. So if we solve for A here by taking times 25 on each side, we get 11 here, and then plus 150, we get 161. So A is 161. The probability of X being less than or equal to 161 is 67%.